Okay, so let's talk a little bit about physics. All right, so first things first, what is physics in the first place? Of course, it's one of the main branches of science, blah, blah, blah. And if you look up token definitions, you'll often see it described as the study of energy, which is a pretty broad description, blah, 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 blah. And I don't really like to think about it that way. The way I like to think about physics more specifically, the way I like to think of it and define it is I like to think about it as how stuff works. And that's the big thing for me, is how stuff works. Now, stuff can mean lots of different things, whether it's a car or the universe or baseball or anything you want. It doesn't make any difference. Nerf guns, water balloons, just how stuff works. And that's a lot of what physics is how do things work the way they do? Why do they do the things that they do? Stuff like that. So it's a nice way for me to think about physics in general, is how stuff works. Now, of course, when people start thinking about physics, there's different things that pop into their head. There's different stereotypes, that type of stuff. A lot of people think about, formulas and expressions and math and that type of stuff. And we're going to sort of look at that a little bit first. Now, when a lot of people think about physics, this is the type of thing that pops into a lot of people's minds. So you're probably from a college or university or something like that. Big, good old-fashioned blackboard with lots of physics all over it, and there's formulas, and there's like little graphs and diagrams and a whole bunch of stuff going on. And this is what a lot of people think about when they think about physics, is formulas and variables and all that type of stuff. In fact, like at the E equals mc squared and F equals ma, and this is what a lot of people think about when they think about physics. But this is kind of just, this is just one form of representation of how physics works and what physics is about. So I'm going to show you a couple other things in terms of how to look at physics in general. Now, often what you'll see is, or what you'll hear about is sometimes people talk about the four modes or four representations of physics. And it's really, really common to actually look at this way. Now, you've actually been using this for many years in all your science classes, because they're actually kind of hidden in the scientific method and that type of stuff, which has been used since elementary school to do labs and experiments and stuff like that. But there's four main ways or classifications that we try and communicate in physics, and that's what the four modes and that type of stuff is for physics. And what it's really, really about is how to communicate. Whether it's something really, really, really simple, whether something is unbelievably complicated, there's four typical ways that it's done. Now, some things lean to work better with one mode or a couple of modes other than others. That's one of the reasons we want to have different ways to communicate. We've got four main ways, because not everything works very well with one mode or another mode. So let's sort of look at the four modes and four different things that we typically use. Now, the first one is often recalled the physical or sometimes the conceptual mode of representation. Now, this is often where things start. This is where you sort of see something. There's an actual physical representation, or you do a sort of a what if type question in your head. So that's a more of a conceptual type thing. So you see something, sort of a what if goes off in your head and that type of stuff, and sort of triggers everything going along. So this sort of the way I like to think about it is sort of triggers. This sort of triggers the curiosity. This triggers what is going on in your brain to try and figure out how stuff works. Now, it could be something really simple, like a car going by, and you're wondering how a car works. Or when I was younger, electronics. How do electronics work? And you want to tear apart the electronics to see how things are working inside, or anything. It doesn't matter how simple it is. It doesn't matter how complicated it is. It could be how does the Big Bang work, and where did the universe come from? It doesn't matter how big or how small. There's something that triggers your curiosity, triggers your imagination, and makes you want to try and figure out how things work and how things do the things that they do. Now, this often kicks into the second mode, which is the numerical. And of course, numerical has to, of course, to do with numbers. So, I mean, that's pretty self-explanatory. So this is where we have to try and use numbers. Now, what do we need numbers for? Well, numbers are really good for a few different things. They allow us to both track and record information. It allows us to compare values and compare things with different types of measurements. And really, it's the main thing that we have in order to actually quantify different things. And pretty much everything out there can be quantified in some way. So we get the numbers, we compare masses, we compare speeds, we compare forces, we track wavelengths of light to compare them, frequencies of sound. There's so many different things that can be quantified, so we can use them and we can calculate things and we can chart them and we can compare values. There's so many different things that numbers are used for in order to actually do stuff. And this is, the data kicks in. So collecting data, making charts, and that type of stuff. So we use numbers to track things, to record the data, to compare values, that type of stuff. And of course, one of the most common things to do after you have numbers is to graph it. And this is where the graphical mode kicks in. Now, graphs are really, really, really important. One of the token things and most important things that graphs are really important for is you can actually allows you to actually see the numbers that you're using in the first place. Numbers are really abstract, and actually just looking at a giant chart of numbers to see what's actually going on is almost impossible unless you really, really know what you're doing. So this is where the graphical stuff kicks in. It allows you to actually visualize and see the numbers, and you can actually look for things like trends and things like patterns and all that type of stuff. And that's really, really important. Is a straight line or is a curve? Is there any correlation whatsoever? And graphs are pretty much the only way you can do that, especially when you're dealing with like hundreds of sets of numbers or thousands of sets of numbers. You can look for trends, you can look for patterns, you can look for relationships between numbers, you can look for connections. So it's really, really, really important. That's one of the reasons you guys have been working on graphs for like the last couple of years in math classes of that. So you start applying it to this type of thing. But the other thing, of course, it allows you to do is you can actually also extract values. Things like slope and intercepts, which does sound really familiar from the last couple of years of math, because slopes and intercepts and that type of stuff, they are really important values on a regular basis. Unless you actually make a graph using the numbers, it's kind of hard to get these values. Okay, so things like slopes, things like intercept, even if you extrapolate, fix that a little bit. I want to say extract, but just technically we want to say extrapolate. If you extrapolate or interpolate, hopefully that sounds a little bit familiar from math class as well, where you get values beyond your data set, you get values within your data set. These things also kick in, and you can't really do that unless you graph. So graphs really kick in and do lots of different things. So typically you start the information, you start with the situation, you extract numbers from it, make charts. Often you take those charts, then you graph them, and this hopefully sounds familiar from pretty much any lab that you've ever done. Now, typically once you get past this, typically the graphical type stuff leads to the fourth model or mode, which is the symbolic. And typically for the symbolic for physics, this is where the formulas kick in, because you can often use the graphs to actually create the formulas. Now, what's interesting about it is it's these formulas, it's this one right here, this last mode is what most people think of when they think of physics, is formulas, 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 formulas. But that's actually the last mode you should actually be thinking of. When you think of physics and you look, this picture with all the, that's only one component of physics, is all the formulas and stuff like that. That's only one part of it. And really, it should be the last one. And this is one of the things that people think about when they think about physics, is all the formulas. And it's one of the things that often causes people the most difficulty with physics, is they focus on this symbolic part and they don't think about where the formulas actually come from. For example, if we go back to one of the more common formulas that often in grade 10 science and mechanics here that you guys take is F equals ma. And, what does F equals ma mean to you? Well, some people say force. Okay, well, some people might say, Newton's laws or something like that. Well, instead of, something like that, you should be able to visualize something. For example, when I think about F equals ma, the first thing that pops into my head is somebody pushing a box. This is what kicks in for me, is that whole physical conceptual thing, because our formulas actually represent situations. And unless you can actually connect the formulas to situations, it actually makes physics very, 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 very difficult. And that's one of the problems that people have, is they focus so much on the math and they focus so much on the algebra and the symbols and the formulas, they lose sight of what's going on, which makes it really, 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 really hard to apply the formulas to the situation. And the whole how stuff works, that's the whole key thing, is you need to be able to apply math to the situation, otherwise it doesn't work out very well. Now, not every situation, can be, physically conceptualized easy, especially really, really abstract stuff. And that's one of the reasons we want to use the 4 modes. It's not just one way or two way. We've got 1, 2, 3, 4. And not everybody's really, really strong at formulas, which is number 4, but they're really strong at the physical conceptual. They're really good at the actual hands-on type stuff. Some people are really good at graphs. Some people are good with numbers. It's the balancing of these 4 modes and the balancing of these 4 different strategies that helps you to get a bigger conceptual idea of what's actually going on in a situation. It's really, really not a good idea just to rely on one. If all you can do is formulas, you're not going to do good in physics. It's just the way it is. You have to have some connection to the situation and what's going on in order for things to sort of tie together. So maybe you're not very good at algebra, you're not really good at manipulating formulas, but you can balance that out with some of the other 3. And hopefully you've got strengths in 1, maybe 2, maybe 3, hopefully all 4. And if you don't, you can use your strengths in the other ones to balance things out. I've literally taught thousands of physics students, and some kids are just fantastic at math skills. They're great math skills, but they're not very good at physics because they had a really, really hard time actually connecting it to the actual situation, which would be more number 1. On the other hand, I've had students who took physics who are really, really good at number 1, the connecting it to real life and seeing the physics in situations, but their math skills weren't as strong. So they had a little trouble calculating stuff, but they still had a really good physics understanding of what was happening in the situation. So these are the 4 modes, and you want to try and get the balance of these 4 modes as best as you can. You try not to rely on 1 or maybe 2. You want to try and be able to connect to all 4 as best you can. But it's the balancing of these 4, and it's not just about the math. It's not just about what the algebra is saying. For example, if I look at this picture of this guy doing a physics lecture, whatever it is, I see one really important thing missing. I don't see any toys. I don't see any gadgets. I don't see any demos. I don't see any of this really, unless it's something really, really abstract, conceptual. But if this is like a high school physics class or something like that, especially, and this is like basic mechanics, where's the Hot Wheels track? Where's the Nerf gun? Where's the ramps? Where's the swinging whatever? Where's the gadgets, the toys, and that type of stuff? And that's where that physical conceptual stuff really kicks in, because that's where you want to start. You want to start with, hey, that's cool. How does that work? Which then can lead to the numerical and the graphical and symbolic. One of the worst ways to learn physics and interact with physics and start with physics is to start with a formula, because that should be more the end point, not the beginning. And it's a lot harder to start with a formula and then backtrack than to start with something that's really, really, really neat. And how many times when you're a kid, did you see something really cool and go, how does that work? Like, go to an amusement park, watching roller coasters. The physics in roller coasters is absolutely amazing. But nobody starts with the formula. You start looking at the roller coaster and go, hey, that roller coaster is really cool. I wonder how that works. Then eventually you can learn the physics of roller coasters. Okay, so these are the 4 modes, and they all sort of link together. But again, don't just think about physics as the formulas. It's a nice balance of all these different things as best you can.